Hello and welcome to Chapter 12. In this chapter, I'd like us to have a look at a tool which lets us visualize how much of the heap is currently being used. We need a reason to do that, so I'm going to devote this chapter to revisiting something I said in the last chapter about how Java avoids memory leaks. I stated this because the Java virtual machine will automatically release all of its allocated memory back to the operating system when the application finishes. This means that a traditional leak is not possible, at least assuming that the Java virtual machine is correctly implemented. But some leaks are possible, and I'm going to refer to these as soft leaks. This isn't an official term, but I'm going to call a soft leak where you have written code, or maybe a third-party library you're using contains code, that somehow keeps an object live even though you're never going to use it again. This object should be garbage, but Java never considers it as such because it's referenced from somewhere on the stack. Now, in many circumstances, this isn't going to be a major problem because when the program ends, the virtual machine will perform the free call and the memory will be released at that point, so the memory won't be lost to the operating system. But while your application is running, you are holding memory within the heap that can never be used again, so you are running the risk of possibly running out of available heap space. On a long-running application, such as a web server, this is a real possibility. So I'd like to look at an example of a soft leak, and I've created an example project for this chapter, and you'll find it in the starting workspace. It's called Soft Leaks. So let's load up that project and look at it in our IDE. I'm going to talk through the basics of this application, although we won't look at every line of code in detail. The idea is that I've written a actually not very good application which is going to contain a memory leak. It's going to store references to objects that are no longer needed unnecessarily. And I'm doing that so that we can understand the impact that this has on the heap. So we're going to start with the customer class. And this is really then just an object which defines a customer. It's got two private attributes called ID and name. We set the name in the constructor for this class, and the ID has a set method, and then there's a toString. And that's all there is in this customer class. Next, let's have a look at the customer manager class. Well, this class has a private array list of customers called customers, and there are methods called addCustomer, which will add a customer to the array list, and getNextCustomer, which, well, this is where the problem's going to turn out to be, but the idea is this will remove a customer from the array list. The idea is that our customer manager class is acting like a queue. There's going to be processes within our application which are going to add customers to the list, and when they're ready to be processed, then some function is going to remove them from the list by calling the getNextCustomer method. And there's a howManyCustomers method which will just tell us how many customers are currently in the array list. So the idea then is that this project is a simple type of queue. Now, obviously you wouldn't normally implement a queue like this, but I've done it in this way so that we can see the issue and so that it's a relatively easy to follow, understandable example. So we'll just think of the array list as being a storage space for customer objects that should be growing and shrinking over time. This is a multi-threaded application so that we can simulate multiple clients interacting with this array list, and so I've created some runnable tasks to do the adding and removing. So the generate customer task, I'll just open that one, that contains a never-ending loop which adds new customers to the array list. I'm using here the UUID class just to generate some random names for each customer. Things would go wrong because of the problem we've got very, very quickly. So just to slow things down a bit, I've got a very minuscule thread.sleep here. It's just 2 milliseconds, but that's just so that we can actually see the application run initially before things start to go wrong. So the idea here is that the generate customer task will constantly add new customers to the array list. And the process customer task is doing the opposite. It's effectively removing customers from the array list by calling the getNextCustomer method. As you can see, there's a little bit of code in here to make this task go to sleep for 50 milliseconds if the queue is empty. And well, this is where the processing would take place on the customer if there was one. I've got the Java 8 version of this application open here, and in the Java 8 version I'm using the isPresent method of the customer object. In this instance, customer is an optional of customer, just to check if there's one there. I'm just pointing that out because if you're using the Java 11 version, actually what you'll see here is a slightly different line of code. It will say if customer.isEmpty. The only reason for that is that I wrote the Java 11 version first, and then when I went to convert this to Java 8, I realized that the optional class in Java 8 doesn't have an isEmpty method. So we have to use the not isPresent method. But that's the only difference between the Java 8 and Java 11 versions of this project. So let's finally look at the class called Customer Harness, and this is going to be the runnable class. And what this is going to do is create 10 threads that will be running the generate customer task. So there'll be 10 threads adding customers to our array list and one thread doing the processing. And then in the main thread of this application, once all of those are started, every 5 seconds, it's going to print out to the console how much available memory there is. So I'm going to run this. And initially, at least, we probably won't see anything that's going to be worrying in our console. So we can see that there are, at the moment, 24,000 customers in the queue, and the amount of available memory is quite big. And as this runs, we'll see the amount of memory is going to go down slightly. Actually, it's gone up a bit, probably because there's been some kind of garbage collection. Now it's going down again. But notice that the amount of customers in the queue is not decreasing. And if our processing is working, then I expect this should be going up and down. It's only ever seeming to be going up. In fact, it's staying very close to that top level. So that tells me actually there's something wrong here, although if I wasn't monitoring this, if I'm just looking at the amount of available memory, well, that does appear to be going up and down, so I don't know that there's definitely anything wrong here. I'm going to stop this running. And I guess one of the points of this is that if this was an application that was running for a very long time, then it could potentially run out of memory, but we won't know if that's going to happen or not. So one of the things that is often a good idea is to run applications that are going to run for a long time with a much more constrained amount of memory to see how they perform. Because if there is one of these soft leaks, if there is something that is going to be referencing an object on the heap unnecessarily and keeping that object, then we want the application to run out of memory quite quickly so that we know there's a problem and we can try and find it. So what I'm going to do then is to run this with a much smaller maximum heap size. We've seen how to do this already. We'll be providing a runtime argument to the application. So let's go into our run configurations, and we want to set the maximum heap size. So that's going to be XMX. And I think we'll go for something really small because I want this to crash quite quickly. I'm going to go for 10 megabytes. This application should actually be quite runnable within 10 megabytes if everything's working correctly. So we'll do that and see what happens. So here's our console, and I'm waiting for 5 seconds, and we can see some customers have been processed there. And I let this run for a little bit longer. As you can see, it ran for somewhere between about 15 and 20 seconds, and then we've had a crash. And indeed, we have an out of memory error in the Java heap space.